Welcome to one and all. In today's class, we are going to learn about the open mold processes in the manufacture of fibers. Open mold processes are one of the oldest and most cost-effective methods in the field of composite manufacturing. These techniques are used to produce a fiber reinforced plastic components with relatively simple shapes and moderate strength requirements. Unlike closed mold techniques, that is rapid prototyping, RTM or compression molding, in open molding, the composite is formed and cured in a single-sided mold exposed to the atmosphere. These processes are particularly common in low to medium volume production, prototype development, and industries like marine, automotive, aftermarket infrastructure, and artistic applications. The key open mold processes include hand layup, spray layup, vacuum bagging over open mold, wet layup with resin infusion, filament winding over open mold for specific shapes. And what are the basic principle of open molding? The basic idea is to place reinforcement of fibers. Fibers means a glass, carbon, or amide. So to place reinforcement of fibers into an open mold, then apply a liquid resin. Usually it's a thermoset resin we are using onto it, ensuring thorough impregnation. The resin is allowed to cure at a room temperature or with added heat, resulting in a solid composite pot. Open mold processes are manual or semi-manual, and while they offer flexibility and low tooling cost, they also present limitations in automation, surface finish, and environmental control. Hand layer process. Here, we already studied about hand layer process. Only the overview I'm staying here. It is the simplest form of open molding. Reinforcement material is manually placed in the mold. Resin is applied using brushes or rollers. Curing happens at room temperature or under mild heat, and steps involved in the hand lab or mold preparation, gel coat application, fiber layer, resin application, rolling, curing, trimming, and finishing. All have been discussed in the earlier classes. And the applications are the construction of fabrication of boat hulls, panels, storage tanks, automotive body parts. Next one is the spray layer process. Yeah, the overview of this spray layer process is an extension of hand layer bubble, but resin and chopped fibers are sprayed together into the mold. Faster than hand layer and ideal for thicker and larger pots. The steps involved here are also the same: mold preparation, spray application, rolling, and curing and finishing. But the advantages are quicker and suitable for complex shapes or complex surfaces. It also reduces the manual fiber cutting placement. Limitations are less control over fiber orientation, not ideal for structural components. Next one is a vacuum bagging. It is a over open mold process. Here it combines the hand layup and spray layup with vacuum consolidation. A vacuum bag is placed over the layup and sealed to the mold. Air is evacuated to compact the layers of there, and it removes the voids also. The steps here involved here are layup using hand layup process. Apply, peel, ply, release film, breather cloth. Seal with the vacuum bag and draw the vacuum. Cure under vacuum with or without heat. These are the steps. And the advantages in the vacuum bagging or improved fiber resin ratio, and fewer air voids also existing, better mechanical properties. And the limitations are here, more equipment and prep time is required, more amount of prep time also required. Then another one is called a wet layup with resin infusion. That is a vacuum assisted resin transfer molding. Here, about the wet layup is resin, we can have this dry fiber reinforcements are placed in the open mold. Vacuum pulls resin through the dry layup. Often it is used as a hybrid between open and closed molding. And advantages here is lower void content than spray layup method or hand layup method. And equipment cost is moderate when compared to the other layup methods. And the materials used here are reinforcement materials or glass fiber, carbon fiber, or aramid, that is Kevlar. Resins are polyester, vinyl ester, epoxy. What are the advantages of open mold process? So tooling cost is low. That means only one mold half is required. Some simple and affordable materials only. Ease of setup. That means no need of pressurized equipment suitable for small scale and custom production. Flexibility is easy to modify part design, ideal for prototyping and unique pieces. Large parts are so possible. It is also used for board hulls, tanks, and architectural panels, as well as technical expertise. Initially, it is less. And the limitations we should know for the open molding process, labor intensive. That means manual work leads to higher labor cost and slower production. Variability. That means inconsistent fiber and resin ratios, dependent on operator skill. Limited surface finish. Only one side has good finish. We can expect here. As well as air exposed side may need post processing. Environmental and safety hazards also be there. That means exposure to volatile organic compounds, protective gear, and ventilation necessary. Not ideal for high performance spots. That means the strength and the consistency is lower than the closed mold methods. As well as the industrial applicants, what are the industrial applications of open mold processes? Like said earlier, marine, automotive, architecture, storage, recreation, as well as aerospace and defense also. Comparison with the close molded techniques, tooling, we can have the feature like tooling cost, production speed, surface finish, part quality, environmental safety, automation potential. We can have a comparison with the close molding also. We will see these things in the next class. As a summary of this class is open mold processes in composite fiber manufacturing offer a versatile and cost-effective route to producing fiber-reinforced polymer components, while they may lack the precision and the consistency of closed mold systems. Their simplicity, low startup cost, and the flexibility make them ideal for low volume, large size, or custom applications. As industries move toward sustainability and automation, open molding is also evolving with the vacuum assisted upgrades, low vacuum bagging, VOC resins, and hybrid techniques. It bridging the gap between the traditional craftsmanship and modern manufacturing standards. So that's all in today's class about the preps. We will that is open molding processes in the manufacture of fibers. We will see in the next class with a different topic. Thank you for your presence. Thank you, and all.